Hello, my name is Sonya Davidson. I'm the CEO of H2 Energy now. We look at the world a little bit different than most other people. We're going to go after a space called the energy storage space. And it all starts with a story. When I was young, I spilled some water on the ground. My mom, instead of getting mad at me, took the time to explain some of the principles of water to me. So, like a ripple in a drop in a pile of water that will create circles out of it, every time I went through elementary school, high school, or university, and they mentioned water, I paid attention. Water is a very unique thing, and the more you know about it, the more you can understand the technology and how to do it. It all comes from looking at the world a little bit different, but that's what entrepreneurs do very well. When I see the Earth, I don't see Earth, I see a potential unlimited store of energy. Water is there. If we could just figure out a new way of releasing the water from the Earth and use it for storage, we could change the world. Energy storage is needed. If you compare our process to electrolysis, it actually goes back to a guy named James Clerk Maxwell, who said 4 processes are similar and you can use to go from one to the other. He said electricity, magnetism, electromagnetism, and light are connected. Electricity is the way electrolysis works, and our technology follows electromagnetism. We're both faster, more efficient, less capital cost because we're using electromagnetic waves to disassociate the water molecule. This is needed in space as well as on Earth. Launch vehicles, I remember seeing my first rockets go up, are actually powered by hydrogen. Hydrogen was one of the things that they used to launch these rockets and get the power. Hydrogen is a perfect energy storage medium and can be easily converted back. Energy storage is needed on all different things. If you can solve the problem of energy storage, it will solve problems both on Earth and in space. One of the market segments we looked at in space was the space station. There's a problem with radiation in the space station. If you created a water vapor, water barrier to capture the rays, and then you could use our technology and separate it back to the gases, the hydrogen and oxygen, remove the bad part, and then through a fuel cell, turn it back to electricity and water. Sounds like a perfect solution to me. On the Earth, Shell Oil is now is building stations for hydrogen-based cars. The cost of a hydrogen, when you fill it up at the station, is $13.99 per kilogram, which is equivalent to 1 gallon of gasoline. Our process is only $3.29. It's a dramatic savings. A hydrogen car will go over, per kilogram goes over 81 miles, and it has a range of 300 miles. So it could solve one of the problems on Earth too. Our technology involves a container within a container. From the inner container, which we call the RF cage, we separate the antenna from the water. We radiate the inside of this container with our electromagnetic waves. Therefore, it works because it's based on the stretching of the water molecule, and it separates the gases, the water molecule, into hydrogen and oxygen gas. One of the things we learned, probably from studying water so much, is that not all the energy for disassociation has to be in the form of energy. It could be in the form of heat. So we capture the heat from our gases and run it by the water going into our product. Therefore, we transfer the energy from one to the other, cooling our gases down, which means you need less space to store it, and warming up our water. One of the things I learned But you have to, as an entrepreneur, you have to think outside the box. I happened to read a book by pure coincidence, another ripple in my life, Einstein in Berlin. And one of the things he did was he used thought experiments. So I said, sure, why not? So what I did was I took my water in my mind into space. It forms a nice spherical ball. There's some beautiful videos on YouTube showing it floating around in the space station. A sphere is actually the perfect solution, but it's not exactly what we needed. I didn't want to have to take my product up to space every time I wanted to use it. The next thing I did in my mind was I squished it. I took this volume and I made it to this. I caused a big problem then. Water has a tendency to share energy when it's closer together. I ended up with higher pressure hydrogen, but I ended up also with requiring a lot, decreasing my efficiency in my process. So the way my mind works is I just left it in my head and kept thinking about it in the back of my head. Then one night on the way home, I thought of the solution. I thought of a spider web, seeing a spider web as a child with droplets on it. I said, that's the solution. If I could find a medium, we're using a plastic small micron thing, and spray the water in, I can overcome one of the principles of water, the ability to share energy. Because this droplet cannot share energy with this droplet, therefore when I add energy to it, they disassociate. We use electromagnetic waves based on the radiation of it. We filed our patents. We started off with a patent convention treaty, followed by European and US patents on our technology. They're still pending. Maybe this year, I think we might get them issued. We formed a team. One of the things I learned as an entrepreneur, if you believe in yourself, you have to put yourself out and talk to your friends and tell them about it. So I have chemists, engineers, RF engineers to help me as I was building this. But more than the people and the names that are up there is what they've done. Let me give you a real life example. We were building our antenna and we needed a 50 ohm resistor. So I went and talked to one of my guys, Avigor Shapiro, who's an electrical engineer, and he says, at my company, we used to manufacture these 50 ohm resistors. I'll go get you two. They're at 25, I'll get you two of them because that'll give you the 50. And he goes to his company, and his company stopped making them. But he talked to his boss, and he told him about my company. So his boss and a team got together and built me two special. So you never know what your team can actually bring to the table. And I think that really opens, to me, my mind to when you really believe in your technology. I have five degrees. Started off with oceanography, which was fun. Went back to school and got a degree in business administration, banking and finance, accounting, a degree in commercial lending from the American Institute of Banking, CPA, certified public accountant, and CIA, certified internal auditor. We presented to Weitzman Institute last year. We were one of the finalists in the 2016 Sustainable Entrepreneur of the Year. I want to talk about another market on Earth. A market that is big. It's $369 billion. It's not a small industry anymore. I think the statistics coming out of Europe, it says 100,000 people are working in renewable energy now in Europe. 20% in some countries are now generating their power from that. It's a wonderful technology, a wonderful solution, but it has a limitation. It's tied to when the wind is blowing and the sun is shining. They need storage too. We plan on changing their business model from generation to storage and distribution when needed. One of the things that makes this unique is that we could store it for 12 to 14 hours. Like wind is normally generated in the evening hours, and the peak time of needed is during the middle of the day, which is 14 hours. Right now in Europe, 90% of new builds for power generation is by renewable energy. And the reason that is happening there is not from government subsidies, but it's cheaper. It's reaching parity, and actually it's one of the most efficient ways to building it. We're looking for a small percentage of this $359 billion market, projected to go to $500 billion in a few years, and we think our company will be worth $2 billion in a few years. In the United States, since 2010, 52,000 wind farms are located here now. They're spread all over the nation, and that doesn't include the solar farms, another portion of it. One of the things I learned, I went through in the accelerators, you need to talk to your customers, beginning, frequently, and often. So we talked to Kassira, Ashay Kasai, Pioneer, NL, Panasonic, LG, Poland Ventures, Ibernia, etc. And what they told us was they needed a product that would store power, but they could put in place and leave and forget. They didn't want to have to get involved. When we were validating our product in the marketplace, we found that the need was still very dramatic, and it's a large and growing industry. We validated our product in the market. We've reached proof of principle prototype stage. So yes, we can separate using electromagnetic waves. It took 5 years and a little over 240 tests to get to this stage. Our competitors, the way I always look at it is, right now, the U.S. Department of Energy said a few years ago, if you add up all the storage technologies in the market, you only get 2.3% of our daily needs. So 97.7% of energy has to be generated on demand. It seems like it should be like 75, 25, but 97 to 2.3, that's kind of backwards in my mind. If you want a smart city, you need storage. Storage is the critical missing piece. We do have competitors in the market. ETEM, which is in electrolysis, ABB, which is in batteries, and Fluent Energy, a new corporation that was just formed last year between Siemens and a utility company. But it's a battery storage company again. The majority of stored power is not in electrolysis or batteries. It's actually pumped hydro. You take water, pump it on top of the hill. When you need it, let it roll back down. You need a lot of land to do that. You need a lot of water. Costs about $500 million to build a process like that. We presented our first academic paper last year at the European Fuel Cell Forum. Autodesk recognized us as one of the leaders in clean technologies and gave us 3D modeling software for the last 5 years. And the Hive was where I went through with my accelerator. Our ask is simple. We're looking for people in our team that we're missing. We don't have all the people. I'm first to admit that. We need an electrical engineer to go to the next stage. We have a very extensive TRL, technology readiness level plan, to go from where we are to the market. We're looking for a lab to go into, and we're looking to raise $1 million to achieve this. We figure we're only 18 months from market, so we're not a long ways. When we were creating a very extensive technology readiness level plan, we found that some parts of it, and parts 5 and 6, are actually taking it to the market and testing it. Since we presented at the Weitzman, we had connections to Holland, which is a big market for wind power, which they actually, because it's created when the market doesn't need it, they're actually paying them not to run right now. And since the grid is open in Europe, some of these utility or these owners of these renewable energy facilities would be willing to give us the power. We could store the power and throw it in the grid, and we could actually be a producer of electricity in Europe as one way. I guess that's it. Thank you. Questions?
First of all, I was really impressed. You did a remarkable job. I think you did an outstanding pitch. You clearly articulate the use cases, your technology, the different addressable market opportunities, the competition. If I can also give you constructive feedback for what it's worth, right? I think what the pitch is lacking a little bit is you clearly describe the problem of the world without H2 energy. I would like to see a little bit more data-driven use case of the world with H2 energy now. So how that multi-billion-dollar market will be impacted, how Enel Green Power that today spend X will be capable to spend A or B and increasing their overall performance or number of stored energy capacity, something like that. But the question I have for you is, so how are you going to use this first $1 million, which I assume is a seed round?
Right.
How are you going to spend money, basically? How is going to be in the still R&D of the product, or is in the go-to-market? So if you would be, speaking to an investor, and I'm ready to, give you $1 million check, I want to know how that $1 million will be spent, and then what is going to happen after that $1 million? What's the bridge, right, to that $1 million?
I actually thought of that question. I have a slide to answer it. We're at TR level 3. We're trying to get to TR level 4, which means we have a validated product with a lab report saying we tested this. When we talked to all these companies, they said, if you can give us that, we'll start partnering with you. So actually, the payback period could be shorter, could be longer. We don't know how long it's going to take to get in the lab. We don't have all the people, so it's people somewhat we're going to spend the money on. We don't have a lab. We need to get into very specialized labs. There are several labs, both in the United States we're in the process of talking to, and elsewhere. Illinois and, let me see, where is it? Pennsylvania and Arizona were the 3 we're talking to right now in the United States. But if we can we know our product works. We don't know, the one question we're trying to find is how much can we push out of one machine before we affect the efficiency of the product? Do we need to capture the oxygen? On Earth, it's not most electrolysis machine releases the oxygen. In space, it might be something we'd want to store. There's several options for separating the gases. There's a existing filter, and then there's a product in the United States called magnet dissonance, which uses the polarity of the molecules to separate them. You can store hydrogen now in a liquid, then add a catalyst to it, and out comes the hydrogen. I think that sort of answers your question. Thank you. I tried to.
Sonya, I'm going to echo Ricardo's comment about the presentation. I think the story is great, and it was very clearly laid out. And I'll also commend you, obviously, about putting your data out there and publishing in academic papers. That's always an icing on the cake. So my question, in not knowing much about this industry, is, do you envision, if I understood you correctly, you said that you can store energy for about 12 to 15 hours or something like that.
Correct.
Do you envision that the product in the future would evolve so that you can store energy for longer periods, reaching 24 hours and potentially beyond that?
Yeah, 48 hours is the goal. In renewable energy, you need to store it for 48 hours because you might have 2 days where you don't have sun. And if you really want to make renewable energy as a real good alternative, turn it from being 7 hours or 8 days to being able to, 8 hours, to being available 24/7. That will change and dramatically change the entire industry. So yes, we believe it's very much. One of the advantages of our technology is, since we're creating hydrogen, we just need to increase the storage capacity of it, and we can store a lot more. and it's easily converted back to electricity, either using a fuel cell or a specially modified generator. Any other questions? I'm sorry.
Quick question about hydrogen storage.
Okay.
So is it safe, you were mentioned that the kind of the storage capacity would be used up, but can't you store hydrogen forever?
You could. It doesn't decrease like batteries. Batteries over time decrease in value. And if it can constantly charge and discharge decreases it. But hydrogen doesn't decrease in value. Normally you can use something very similar to a Mylar, like those balloons you blow up with helium that stay up for a long time. Mylar has the ability to hold hydrogen in it. So most of the containers now going in the cars have a Mylar layer. It's a multi-layered storage thing. So that's one way you can store it too. And it's safe. It's safe. Hydrogen is safe. There's something called the hydrogen economy in the Hydrogen Society in the United States and the hydrogen economy in Europe. It's the same idea. Hydrogen is a perfect solution to what we need. We need to store energy.
What is your biggest technological risk? Your technical risk to get it to TRL-7? And are there any safety concerns in space for use around humans?
Okay, there's a regulatory issue that brought us up that when we were doing our market validation. We realized if one of the markets potentially is a home, store power, people want to go off the grid, we could store their power for them. We figured that was probably the most regulatory issued one we would have. But if we're talking about a solar field or a wind farm, that's the least regulatory. So if we could put it out there and get it and store their energy for them, and then come to the regulators, and we see the next market would be large businesses that want to control their electric cost or start to go to clean energy, then we could go to them and say, well, we've had it in the market so many years, we've moved it, we have a very clean, we have a safe product. One of the things we wanted to build into our technology or our commercial prototype was an ability to monitor it remotely and shut it off.
Okay, so you see no technical risk between now and TRL-7?
No, there's some additional technology we know that we're going to run into, but we don't know of any that at this time. No.
So you're at the early prototype stage. What's the largest volume of water that you have converted to hydrogen oxygen?
Well, I actually did it in my house. So I didn't want to create a lot of hydrogen in my house. So it's actually very small, the amount that we did this time.
So what's the impact of impurities in the water?
We were using fresh water, and we didn't worry about the impurities, and we added salt to it. So we actually prototype using salt water.
And so you haven't done the gas separation to separate out the hydrogen yet?
No. But that's an existing technology. See, there is an existing technology already to exist that using the same thing as in a fuel cell, it's a membrane that you can run both gases by and separate the two.
But they have impurity issues that limit the length of time you can use the membrane. So there are challenges in this. So anyway, you talk about storage for 2 days. What's the limits? How long you can store this?
It's hydrogen. It's hydrogen. My goal was to store so much power. Now, I wasn't thinking the length of the time of storing the hydrogen. I was thinking, how much power can I store?
Okay, thank you.
Sorry.
Excellent presentation. I
Thank you.
really enjoyed walking through your story. And when you talk about storage, you hit the nail right on the head. So that was a really good find. So help me with further understanding the concepts that you're bringing forward. So one is basically a fuel cell, correct? And is there competition between the fuel cell and battery development as far as terrestrial applications? And the second thing is, fuel cells and, it just went out of my head. Go ahead.
No, I was just going to go back to that. Sorry. You mean is there a competition between fuel cells and what?
batteries? Because you know the country is really excited about developing batteries for all different type of applications. So is that a competition or?
I don't really, I don't really think any of them as competition. I mean, they're in the market. It's a very big market, but nobody's storing power. So I don't really think of them as, I know they're competitors, but I'm not worried. In batteries, for instance, because I did validate, what's going on in the industry, I found that the European Union had paid a pilot project to store power in batteries. They were trying to store quite a bit of power, so they needed 4 train loads full of batteries. And it was supposed to go on for 6 months, and because of the charge, discharge, and high pressure on the batteries, within 3 months they had quite a few leaks and had an environmental hazard, so they shut the thing down. Presently, the ones I've seen, they've tried to solve that problem by not sticking them in train cars, but they're putting them in very controlled environments within a very short period of time. I think the one with Siemens and AES is doing that. But I don't see them, I really don't see them. I see them as someone also in energy storage. I can do things they can't do, and they can do things probably I shouldn't be doing. If they really want to put it in someone's house, okay. But there is a market, Panasonic is talking about in Japan, of making hydrogen-based storage systems in the house. And they're either thinking of doing it by transmitting hydrogen through pipes to the houses and generating it somewhere else and storing it somewhere else, or generating hydrogen on site to store solar power too. So both are.
And then one more question. When you looked at the renewable energy, the industry of either solar or wind, they said that if you develop your technology to TRL3, they will be willing to start using it?
Yeah, they're very much, they have a, their pain is the most. That's the expression they told us to use in an accelerator, because they have the grid. They're generating, like, let me take a real life example. Take wind power. It's generated in the middle of the night. They can't use it in the middle of the night, and the way the grid responds to that is they say, well, instead of paying you to take your electricity, you have to pay us to take your electricity. So they're losing money generating this power in the middle of the night. But if they could store that power for 11, 12 hours and throw it during peak demand in the middle of the day, besides getting reimbursed for a little bit when they could sell it, they get reimbursed for a lot. It makes a lot of economic sense for them to do that. And a lot of those companies are talking about partnering with us or doing strategic things on us based on limited markets.
And you said they're willing to partner once you get to
TR
TR3
level
or
4.
4. Okay, so once you do the testing,
Yeah.
then they're willing to start. Okay, thank you very
Yeah,
much.
you need that lab report. I think that's what they're really saying at this point in time.
Okay, thank you.
Thank you. Sure.
I have a loud voice, so I'll try without mic. Okay, so
Can I just?
part of the mic, loud Italian voice will not be loud enough.
For the internet.
Yeah. All right. I have a question on financing.
Okay.
Do you have any view or strategy? What type of money you want to raise? Do you prioritize strategic, institutional, or venture capitalist, or you just don't care? $1 million is $1 million. What's your view?
We're listed on 12 sites right now, and we're going after VC money. We've invested about $110,000. Family, friends, and fools, or FFF,
That's
in
great.
our
That's great.
corporation.
That's called skin in the game.
Yeah. So we've done that. Yeah, that's probably VC is probably the best way to do it.
Right. And then I saw the logo of Enel, and I know that Enel and EDF as well, they just opened their innovation lab in Silicon Valley.
Right.
Enel a few months ago, EDF a few weeks ago. And I was wondering if you are talking to them.
We are, but we're going to talk to this more.
Well, I'd love to take it offline.
Really very interesting. Two quick questions. You're separating the hydrogen and oxygen, you said, using electromagnetic radiation.
No, yeah, correct.
I'm just interested what kind of electromagnetic radiation.
I mean, the frequency?
Yeah. Or
I'd
is
be
that
happy to tell
proprietary?
you. I'd be happy to tell you when I'm not on.
I got it. The other thing I was going to say is that one of my business partners recently invented and deployed an electrolysis, a water electrolysis system on diesel trucks in order to be able to inject hydrogen to get a more efficient fuel burn. And nobody believed we could do it. He did run it on 200 trucks and got a 14% energy fuel efficiency increase. And it was a mixture of the hydrogen and the oxygen, the hydroxyl, that gave it that. Have you thought about if your product is a better margin on the energy input, that it could be really interesting in something along those lines where you're making the hydrogen in place in such a thing like a diesel engine?
There's three things I understand. I had read about those doing that. One of the problems with hydrogen is it burns so hot. If you're injecting it into a piston, you're going to heat up the piston a lot quicker. I don't know what, you could end up, I agree with you, to get increased mileage on it, but I don't know how over the long term, I've never seen anybody really say, does the piston hold up?
Yeah, we're selling millions of dollars worth of it right now.
Okay.
So, it's a public company, but
Okay.
I'm interested in the fact that if you can make the hydrogen on site in the engine at a better margin of efficiency, then it increases your fuel efficiency once again. So just something maybe to think about.
Great. Thank you. Thank you.